Chapter 8, Section 8.1. Now, one method that we use in order to solve an equation and find the value of x is method of square root. Now, when you have equations like x to the power of 2 is equal to 9, when we ask you to find the value, solve for x, when we ask you to find the value, that when you substitute for the x and raise it to the power of 2 is 9, you understand that one number is 3. Because if I take the 3 and raise it to the power of 2, 3 times 3 is 9. There is also negative 3. So it's not just one answer, there are two answers. The second one is negative 3. If you put a negative 3 and parentheses around it, then would be negative 3 times negative 3 is 9. Again, remember, there is a difference between these two. If there is no parentheses, then this is equal to minus 9, because negative is not within the parentheses. You just do this part. But if there is a parenthesis around the negative 3, it's indication that you are taking negative 3 and multiplied by negative 3. So that would be 9. Anyway, so here, this equation has two answers. One is positive 3 and negative 3. And remember, the highest power of x is indication of the total possible answers. So if the power is 2, means you might have up to two answers. So here, x to the power of 2, there are two numbers. Or x2 is equal to 4. What numbers to the power of 2 is 4? X is positive 2 and negative 2, correct? Now, some numbers are easy to guess. So like here, we could tell, well, x has to be 2, or here x has to be 3. But when you just say x2 is equal to 7, it's not easy to find a number that when you raise it to the power of 2 is 7. The reason is that number is a decimal. So how do we find that number? By taking square root. Like this problem, x2 equal to 9. The other way to solve it is this. You put a square root around x2 and plus or minus 1 around 9. See? Here. Then x equal to plus or minus 3. Or like for this one, x2 is 4. You take a square root on the left and also on the right. But on the right, since you know there is always two answers, you should always put a plus and minus. Means there are two answers, plus or negative. This side, remember, if the power and the root are equal, x is released from the radicals. And here, radical 4 is 2. So there are two answers. So in that case, x2 equal to 7 is, we don't have to put radical on the top of this anymore, because you understand that a minute you take a square root of x2 is always x. So you could skip this part and just say x is plus or minus radical 7. So anytime you want to take a square root of what you have on either side, you have to put a plus or minus. But it doesn't have to be x. Let's say you have something like x minus 1 to the power of 2 equal to 5, for instance. Look at this. The whole parenthesis is to the power of 2, okay? So when you put a radical at the top and the plus or minus radical here, by doing that, x minus 1 always released from the radical. It's just like how x is released from the radical because the 2 and 2 are the same. Here, the same thing. So when you take a square root of x minus 1 to the power of 2, x minus 1 is released from the radical. And here you have plus or minus radical 5. So in that case, if I add 1 to both sides, then x has two answers, is plus or minus radical 5 plus 1, which is what? radical 5 plus 1 is one answer, and minus radical 5 plus 1 is another answer. Or you could just write x is 1 plus radical 5, and x is 1 minus radical 5. Either one is correct. Okay, so that is method of square root. So now here, x2 equal to 81. So here I show you the solutions. Look, the first one. I don't have to put a square root on the top anyway, because I know if I put a square root of x2 is always x. So you could always skip that step. But on the right, you should put plus or minus radical 81, which when you use your calculator, radical 81 is 9, or radical 81 is 9 to power of 2. See? When you take a square root of both sides, this is just the x, and here plus or minus radical 45. And 45 is, sometimes you want you to simplify this. Means you break it into 9 times 5. 9 is 3 to power of 2. 3, since the power is 2 and the root is 3, the root is 2, 3 is released from the radical. So what is left under the radical is just 5. So what is the answer? Plus 3 radical 5 and minus radical 5, 3 radical 5. See? When you put a square root here and a square root here, you don't need to put a square root anymore because you understand that x plus 8 is released. But on the right side, you have plus or minus, always plus or minus on the right side because there are two answers. Okay. So plus or minus radical 9 is plus or minus 3. So one is x is, if I put a negative 8 here and negative 8, see? One answer is negative 5, one is negative 11. Same thing here. You put a square root here and a square root there, see? Right? And then this 3x plus 5 is coming out of the radical. Is it plus or minus radical 12? See, as I said, you don't need to put this one anymore if you understand how it works. The minute you put a square root both sides, this 3x plus 5, 2 and 2 cancel, they come out. And the rest is here. Now I need to take 5 to the other side. So here, you put a 5 on this side, divide by 3. See, there are two answers. One answer is minus 5 plus 2 radical 3 over 3. One is negative 5 minus 2 radical 3 over 3. And this one is very simple. So you take the 2. Anytime you want to, remember, anytime you want to take a square root of both sides, it shouldn't be any number here. See? No number next to x2, no number next to parentheses. You shouldn't have anything here. So like if I have something like that, look, if I have like x minus 1 to power of 2 equal to 5, and if there is I don't know, if there is like a 3 here, you cannot take a square root. Because if you do that, then x minus 1 to power of 2, x minus 1 is the only one that comes out, 3 doesn't. So in that case, before you work on these problems, you have to divide both sides by 3 first. So x minus 1 to power of 2, or anything to power of 2, has to be alone with no number next to it. Why? Because when I take a square root, see, then because 2 and 2 cancel, x minus 1 is released from the radical. But if there is a number next to it, when you put a square root here, you cannot release the 3 because the power is not 2. So remember that. All right. Now, this one, when you take something and raise it to power of 2, the answer is always positive. So these problems, if we ask for real solution, there's no solution from the beginning, because if you take any number and substitute for x, and multiply by 4 and subtract 3. It doesn't matter whether inside the parentheses you have positive or negative. When you raise it to power of 2, it's always positive, but you have a negative number on this side. That means there is no real solution. However, there are some imaginary solutions which deal with the I, complex number. So what we do is we just take a square root here again, a square root there, right? But then we understand that if you have, I write it here for you. If you, I was radical minus 1, right? So if I have radical minus 49, you could write it as radical 49 times radical negative 1, and negative 1 is the I, and radical 49 is the 7. So radical minus 49 is 7I. So you don't have a real answer, but you do have imaginary. So anytime you have a negative under the radical with an even root, you don't have any real, because like if I use my calculator and take a square root of negative 49 calculator, give me error. Why? Because you cannot have the negative number under the radical when the root is even. But you could have imaginary number. So what you do is you remove the negative from the radical and you put I, then radical 49 is I. So that's what we have here. So this would be 7I. This should be wrong. You need to correct that on your print. So plus or minus 7I, and then this rest is you just take the 3 to the other side and divide by 2. So that gives you the value of x. X is 3 plus 7I divided by 2, and 3 minus 7I divided by 2. Now, this is the second method. They call it method of completing the square. So start with problem number 7. We have method of completing square. The second method. So we already talked about square root. Now the second method is method of completing square. And this method is also to solve the second degree equations. Okay, when they say second degree equation, they are talking about ax2 plus bx plus c equal to 0. Second degree equation when the highest power of x is 2. So one method was method of square root that we explained a few minutes ago, and this is now we want to talk about the second method. Okay. So number 7, you want to use that, and first we want to practice how to use method of completing a square. If you have, there is a formula that we had in algebra that if you have a minus b to power of 2, that is also equal to a to power of 2 minus twice of this plus b to power of 2. Or if you have a plus b to power of 2 is a2 plus 2ab plus b2. So we had these two formula in algebra. All right, so if I have x to power of 2 plus 4x plus 4. Let's say in this example I have this. The first one is in perfect square, x2. 4 is 2 to power of 2. So A2, B2, and what do you have in the middle? Twice of AB means you take these two, multiply A times B, and then multiply by 2. See, you take these two, which is 2x, right? And then multiply by 2, that gives you 4x. So this problem has the right part. And if you want to find the one on the left, this is equal to x plus 2 to power of 2. X plus 2 to power of 2 is x to power of 2. You multiply these two, which is 2x times 2, and then 2 to power of 2. So let's say you have something like this. You have x2, and here you have 9, and in the middle you have 6x. Let's look at this one now. x2 minus 6x plus 1. The first one is in perfect square. 9 is 3 to power of 2. And then if you take these two and multiply, which is 3x, and take that and multiply by 2, that gives you 6x. And which formula is this? Is the one that has a negative. If there is a negative here, then you have a negative there. See? So this one would be x minus 3 to power of 2. So what we are trying to do here, we are trying like here, on this one, which is number 8. Let's look to see what number 8 is. Oh, let's do number 7 first. Sorry, 7. Add the proper constant to the binomial. So the resulting trinomial. Trinomial means when you have 3 terms. Binomial when you have 2 terms. See, right now you just see 2 terms. They're saying what should you add here in order to come up with that formula. Okay. So here, P2 minus 14P. You take half of this 14, which is 7. You raise it to power of 2, you put it here, and then you subtract it. See, because you cannot just add something to here. Like if I have 5 plus 8, which I know is 13, if you just add here negative 3, positive 3, does that change anything? No, because still the outcome is 13, right? Or if I have 9 plus 10, which we know is 19. Does that change if I just say minus 5 to power of 2 plus 5 to power of 2? No, because this is negative 25 plus 25, so you still have 19. So here, when you have P2 minus 14P, we just add 49 and subtract 49. We say nothing changed. But doing that, then these 3 is P minus 7 to power of 2, see? Because you take the 7 and multiply by P, 7P times 2, it gives you 14. And because it's a negative, this is a negative, minus 49. So you change P2 minus 14P to something like this. So P2 minus 14P now is this. Or here on number 8. Number 8, they say solve these equations by completing this square. X2 plus 4x plus 1, right? So we want to solve it. So what we do here is you take half of this 4, which is 2. You raise it to power of 2, plus 2 power of 2, minus 2 power. And we move this one to the other side because we really need to work with just these 2 terms. The term that has x, we need to work on this. We don't need the number, so we put that in the other side. So now these 3 is x plus 2 to power of 2, minus 4, minus 1. And then I remove minus 4 to the other side. This is positive 4, 3, see? And now the rest from here down is method of completing a square. See that? Get this one? We want to solve this. First, you need to move numbers to the other side because we always deal with just these two terms that has an x in it. Then you take half of this 6, which is 3, and write here 3 to the power of 2 minus 3 to the power of 2 equal to 2. Then this 3 is x plus 3 to the power of 2 according to that formula. Minus 9 equal to 2. And then I'll move minus 9 to this side. 9 plus 2 is 11. Now from here, we use method of square root. Method of square root, we use it from here. With, this side, it would just, the 2 goes away. And like that. Okay. Now, to use this formula or this method, you should not have any number next to x2. See? Then next to x2, you should have just 1 if you want to use this method. So here, in these problems, I have a number here. So first, I got to get rid of this 4 because I don't want to have any number next to whatever the power of 2 is. So I divide everything by 4 first. Okay, so this is what you have. Half of 3 is 3 half. You add 3 half to the power of 2 minus 3 half to the power of 2, and we move 4 to the other side. Then this 3 is that this one is 9 over 4. Remember, minus this negative is not in the parentheses, okay? So negative is outside the parentheses. So 3 half to the power of 2 is 9 over 4. Move 9 over 4 to the other side, which is half. Then from here is a square root. You take a square root of both sides, plus or minus this. So it is not as easy as the other problems because you have to deal with the fractions, Okay. Oh, look at this one. First, I don't want to have any number sitting next to x, like I don't want it to. So what I do is I divide everything by 2 first. See? Then, what is half of 5 half? 5 over 4. You know how to do that? 5 over 2. You want to take this divided by 2, right? Look, you want to take this and divide it by 2 because you always take the number and divide by 2, correct? Which is 5 half multiplied by 1 half. Remember, anything in the division of fraction, you could always switch division to multiplications and reversing the second one. So that would make it what? 5 over 4. That's why you have 5 over 4 here. So half of this is 5 over 4. You raise it to power of 2 and then you subtract it. Then this 3 is that. This one is this. Take it to the other side. The rest is just 16 and 2. You want this to be 16. So multiply this by 8. This by multiplied by 8. Take a square root of both sides. And then we move this to the other side and so on. So this all is just the algebra and how to do the calculation and stuff for these problems. And then here, first you take the 2 to the other side because we want to deal with just y2 plus 2y. We want to just deal with this, okay? So we take the 2 to the other side. And then you add half of 2. Half of 2 is 1. So you add 1 to power of 2 minus 1 to power of 2. This 3 is that -1, -2. Take -1 to the other side is +1, and take a square. From here again is a square root method. So these problems, method of completing the square, first you start with completing the square and then a square root. See, first move the number to the other side because we just want to work with the first two terms that has variables in it. Half of 7 is 7/2 to power of 2 minus. Then this 3 is at 49. Then move 49 to the other side. See, take a square root from here is the square root method. And so on. Ooh, look at this one. You don't need, you should not have any number next to x. So first I have to divide everything by this 9 because I always want to have 1 here. Now what you have is this, x2 plus 15. Again, what is half of 59? Again, remember, half of 59? Because you have to take half of this and put it here to power of 2, right? What is half of 59? 59 divided by 2, or 2/1. Or 15/9 multiplied by 1/2, which is what? 15/18. That's why you have 15/18 here. Then you take this. Then this 3 is that, this one, and then you take this to the other side. See? It's a long problem, you see that? So that would be the end of this sections.